Hello, Tom from Every Step Calculus, everystepphysics.com. I just throw this video in here because I was kind of pissed at it, the way this guy answered the problem for this person on Yahoo who asked the question. And you know, you're always fighting people that don't know, you know, really great math technique and stuff like that too in my business, or in this, certainly the calculus or math business. And for instance, he has, the answer is 288 pi, which is correct, you know, but now they got something that's weird in here, which is x greater than 0. There's nothing in any problem in the shell method or disk or anything where you just give you this nebulous range of trying to figure out the problem. In other words, when you put this 6 plus 5x equal to x squared, you know, you're going to come up with, just like he says here, with a -1 and a 6, which is true, but he's got x greater than 0. So, you know, my programs, of course, when I run it, they find out that he really meant x equals 0, okay, and that's the reason he's not getting 288 pi for the answer. And yet this guy, who seems to be kind of like a professor or something, you know, and he's, you know, the first thing you should try by sketching a graph of the region being revolved. The bounds are the parabola and the line. The line is above the parabola throughout the region. Well, that's all true. That's all calculus is graphing, and you know, in a million different ways of graphing, you know, with functions, you know, and what's so pathetic about calculus. And then so they find the limits, you know, and get this limits here. Now he puts down a -1, but then what about the guy saying that x is greater than 0? See? And so the way this works out, well, I'll show you how my programs do it. And then notice that if you were going to study this and then go take a test on this problem, you know, what would you do first? What are you going to write down in your paper? Where's the formula? What's happening? You know, you want to write down about 6 steps on this thing, like my programs do, and get to the next problem and get the heck out of calculus, never to touch it again, okay? Even if you work at NASA or become a physicist or whatever, you'll never use calculus again, ever. It solves nothing useful. And all the things it does solve, you can use other formulas for it anyways if you wanted to do it, but you never even want to use what they're trying to solve, you know. Big thing is growth of population and stuff like that, you know. But anyways, let's do this problem here. Index 8 to get to my menu. I've already scrolled here, so I got a shell method here, which we're going to use because this is a shell method. We're going to certainly go down on my programs, and you scroll, you know, with this down here, we're going to scroll up here to shell method, press enter. And we're going to choose the vertical axis because it says about the y-axis. And so we're going to choose number 2. When it's busy here, it's loading the program. Just does it once when you first load the program, and then it's fast after that. And so I show you, here's what you write down in your paper: 2 pi times the integral of px over hx, okay, dx, okay. Now that's what you're going to write on your paper. So you got 2 points, 3 points, just because you know the formula. Where's the formula here? He's got it down here, but you don't know the formula, what you're supposed to be using, you know. So we're going to enter the 2 values for y, okay. First one is, so we're going to have to press alpha first in my programs, alpha x squared, and then alpha 5 times x plus 6. Another thing in these programs like shell and stuff, notice the ignorant, easy little functions that they have, you know, and yet there's some teachers will say, oh, we wouldn't have known the volume of Saturn if we didn't know calculus, or some bullshit like that, you know. But I mean, notice these simple, stupid little functions that they give you. And it's the same thing throughout all of calculus. And I say it's okay, I would give you a chance to answer it if you don't. And so then you subtract the two functions from each other, okay, to get them into one. So here's the answer for that, okay. Already you got 10 points on your problem. Are two values for x given for the limits? No. I don't see two, do you? Is there an about x given? No. About x given, when you see the rotating about the x equals 9 or something, that means that you have to change the formula, the radius of x minus 9 for the radius, which is p of x, right, in the formula. So I'm going to say no. We scroll down, could press 2, I have scrolled down here, do it. So now the radius is x, just simple x, okay? Is a single x given? No. But he has greater than 0. No, if this was x equals 0, we would say yes. Well, let's say yes. And let's enter alpha 0. Now, what's a drag about this problem is that x equals 0 doesn't even make any sense, because they cross the straight line here at minus 1 and 6, okay? Which, when you make these functions equal to each other, that's what it turns out to be, x equals minus 1 or x equals 6. So now we got minus 1 and 6 for the, but that's not going to come up. I'll show you what it comes up as. Notice that the 6 computes, we integrated, of course, doing the integration with the, comes up to 288 pi, okay? But now you got minus 1, you got to compute that if you're going to do minus 1, which is 13 pi over 6. And then when you use the common denominator, it turns out to be 1715 pi over 6, or 898 cubic units. So let's go back. We're going to choose the vertical axis again. And let's enter the function again. Alpha x squared alpha 5 times x plus 6. Okay, say it's okay. There's the height, h of x, right here. Our two values for x given. When we know that it's minus 1 or 6, you know, but you can't, since he's got more than x equals greater than 0, but he meant x equals 0. So if we know that, and we can put down the, we can say yes, and put down the alpha 0 for the lower limit, alpha 6 for the upper one. I show you what you've entered again. Here's the function and here's the limits. I say okay. Now if he said limit around like say rotating about x equals 4 or something, you'd put 4 in there, you'd say yes here, and you'd put 4 in, and then that would change the radius to x minus 4, okay, instead of just x. But because you didn't do that, it's just x for the radius. So now let's do the problem, okay? Here we have 2 pi, here's the limits, the integral of p of x here, which is x, and h of x, which is the, what we determined for the height. And then he's setting this baloney about calculus where you're going to, and then put a skinny vertical rectangle within the region, okay, and its thickness is dx and its height is top curve, you know, and then In disk methods, they have a million disks that they're putting in so far, but the calculations don't even have anything to do with rectangles, you know, but calculus always shows that in their books and everything else, you know. It's a bunch of baloney, you know. Anyways, let's do the calculations. We calculate the px times h of x right here, okay. Now notice you want to get this problem, never to touch this problem again, get an A on your test and get the hell out of there. Volume, now we're going to integrate, which we integrated here. Here's the integration. And it's x equals 6, it's 288 pi. At x equals 0, it's 0. So we have 288 pi less 0. And the answer is 288 pi, which he's wanted to get here, you know. But the only way you can get it is to have x equals 0 for the limit, okay? So anyway, sorry for my bitching about this stuff, but I mean, I work with this every day, and calculus annoys me so bad. The only one who should be taking calculus is pathetic math majors, you know. Let them deal with it, not us, real people, okay? So anyways, go to my site, and if you would, go to the right of the video screen here and click on that box on the right with the calculator in there, and maybe you can subscribe to my site and hear more of my bitches, or see great solving and sane solving of these problems, okay? So go to my site, buy my programs, and they're worth every penny. You'll throw away your calculus book, throw away your study materials, because this is the proper notes of every problem in calculus, okay? Or certainly most of them. There's millions of functions, so I can't do every one of them, but certainly for tests I try to do everything on a test, okay? And you'll pass any test with calculus with this, okay? So go to my site, buy my programs, and have a good time passing calculus. Hey, have a good one.